this recording is for the people who are gone during section 3-4. We are only doing half of this section today. We're going to finish the rest of it on Monday. So 3-4, solving quadratic equations by factoring. We are still trying to solve them, not by graphing though. Okay, what does the solution look like?
Wherever it hits the x.
Wherever it hits the x-axis. So we're still trying to find these places, basically right here. Okay, you're trying to find the x-intercepts, basically, or the zeros. Okay, but we're trying to do it without graphing. We don't want to graph. We don't want to do that anymore. No graphing. Okay. Now, before we start factoring, they're going to do something like reverse factoring, basically. I'm going to start with an example over here. So this is not on your sheet. Let's do x squared plus 5x plus 6, okay? And if I'm trying to break him, I'm going to say equals 0. If I'm trying to break him down, break that equation down, how can I do that?
Put 6 on the right side.
Nope, I don't want to put 6 on the right side.
Nope.
I want to break him down like that, into 2 pieces. I want to break him down into 2 pieces. Okay? You say to yourself, what can you multiply to get 6, but when you add them, give you 5? 3 and 2. X plus 3, x plus 2. Some of you said 2 and then 3. Does it matter what order? No. Equals 0. X plus 3, x plus 2. Okay? Now, as soon as I have it like this, what do I do if I want to solve for x? X plus 3 equals 0 and x plus 2 equals 0. Right? Yeah? Yes, yes. And then I'm going to subtract 3, so x equals negative 3. Yeah? And I subtract 2 and x equals negative 2. Okay? Good? Those are my answers. That's how I solve that. Okay? Now, what do these two guys mean?
That's where it crosses.
Those are my zeros. That's where it crosses the x-axis on the graph. Yes, exactly. Okay? Now, they're wanting us to do that in the reverse order. In example 1, they say, and I'm going to change this. I don't want to deal with fractions yet until we're really good at this. So change that to a negative 3 instead of a 1/3. I don't want to deal with fractions until we're really good at this. Okay? All right, so write a quadratic equation. They want us to write something like this. But they are giving me these 2 things. So instead of starting with this and working down, they're giving us these 2 and working back up. Does that make sense? Okay? Starting here, working back up. This is very easy process, right? So when I have negative 3 and 6 are my answers, okay? Negative 3 and 6 is my answers. That means x equals negative 3 and x equals 6, okay? That's what those guys look like. We're starting at this step. That's where you're starting. Negative 3 and 6, okay? Now, I want to get to this step right here where he's in parentheses. Okay? Do you guys see? Going from this x equals negative 3 up to here in the parentheses, what happens? If x equals negative 3, then in parentheses, it's actually x plus 3, right? Okay, so if x equals negative 3 here, this is x plus 3 here, right? Because when you set it equal to 0 is when it becomes the opposite symbol, right? Okay, so the other one is x minus 6, exactly. Okay, now, how do I get it from this step to this one?
You have to figure out what.
Just multiply it through.
Oh, yeah.
Foil, you foil, F-O-I-L. So at this point, you foil, and then we are almost done. Okay? Now we're going to foil. So the first piece is that I'm multiplying x times x. X squared. Okay? X times negative 6 is the outside pieces. Negative 6x. 3 and x are my inside pieces. Plus 3x. And 3 times negative 6 is negative 18. Am I done?
No, you have to group them.
No, you have to not group. Yep, squish them together. You need to combine like terms. Those two go together, right? X squared won't go with anybody, so he's going to stay like that. Okay? Negative 6x and 3x. Negative 3x minus 18. That's what he is right there like that. I am done now. Yes. No, because that would be, if I set that equal to 0, that would be coming back to this way, right? Yep. So, they asked me, write a quadratic equation. Is this a quadratic equation?
Yes.
Yes. And these are the zeros, or those are the roots. Done. I'm done. I've done what it asked me to do. Good? Okay, now, my factoring methods. We're going to start factoring now. So we're working back the other direction. We're doing this thing right here, okay? There are 4 factoring methods. We're going to do the first 2 today. So the first one is greatest common factor, GCF, okay? And the second one is difference of squares. We're just going to do those 2 today, all right? I will go ahead and write out what the third and fourth one are. Number 3 is a simple trinomial. And number 4 is a complex trinomial. We're going to do those on Monday. Nomial. We're going to do those on Monday, okay? These 2 we're going to do today, a GCF and a difference of squares. Those are the today ones, okay? A complex trinomial, just so you know, we've already done one. It's this one. This is a simple trinomial. This is a simple one. We've already done one, okay? But we're going to do greatest common factor, difference of squares today. All right. Here's my first greatest common factor. When you see stuff that looks like this, you have to factor them out using what goes into both of them. So I'm looking at these 2 pieces and saying, what will come out of both of those pieces? Okay? Done? Okay. Perfect. We'll leave that in here.
We'll probably have to change it. I have to change it.
Yeah, I know. That's fine. That's fine. Ah, 7th graders. Who loves 7th graders? They're getting a seating chart on Friday, so they're really going to hate me next Friday.
They're
That's fine. All right. So these 2 pieces, what will come out of both of those pieces? Somebody already said it. 8 and
8 and 1.
8 and
4.
What?
What are you getting at, Cometry?
what goes into both 16x squared and 8x? You're right. 8 comes out.
X.
Oh, the x will come out, right?
Yeah.
So don't forget him, right? Don't forget him. An x will come out of all of them, all right? Now, people get confused with this all the time. If I take 8 out of 16, what's left over?
2x.
Okay? The correct answer is 2x, but you know how many times I've seen people write 8 in there? Because 8 plus 8 will give me 16, right? But you're not adding, you are dividing, right? Okay? So divide, don't add, all right? Now, done? Because if I take 8x away, it'll be gone, right?
But you're dividing, so you gotta leave something behind. You gotta have 1.
Plus 1.
You do plus 1, okay? If this is completely gone when you take it out, put a plus 1 in there still, because look at this, and if I just mentally check to see, if I distribute that back through, 8x times 2x is 16x squared, 8x times 1 is 8x. If I put nothing here, pretend that there's nothing there, then it would just be 16x squared, and there would be nothing left over, right? So you have to have a 1 to hold the place, right? All right, now, I'm almost done. I set that equal to 0. I have 2 pieces. Even though this one is not in parentheses, he's still a person, right? He's still there. And I have this guy right here. I set both of those equal to 0, just like I did up here. Just like I did up there. I set x plus 3 equal to 0, x plus 2 equal to 0. So I go down here. 8x equals 0, and 2x plus 1 equals 0. Okay? Now, how do you solve for x on this one? Divide by 8. Divide by 8. So x is 0 divided by 8 is
0.
0. 0 divided by 8 is 0, okay? Then what do you do for the second piece? Minus 1. Minus 1. So 2x equals negative 1, right? And then divide by 2, x is, just leave it as negative 1/2. Don't convert it to a decimal, okay? Now, that's all fine and great. 0 and negative 1/2 are my answers, but what does that mean?
That is
No,
zero.
That's where it crosses the x.
That's where it crosses the x-axis. So 0 and negative 1/2, which is like right here, is gonna, here's what my parabola looks like.
Oh.
Super, super skinny, right? That's what he looks like. So when we're doing this, keep that in mind, that those 2 answers is where my parabola crosses, right? That's where he's gonna cross, all right? If we're doing it but we don't know what it means, it doesn't help. All right, part B, same thing. What goes into 21x squared and 14x? 7. 7 and x. We're going to take a 7x out of both pieces, okay? Take 7x out of 21x squared. What's left? 3 and x. Okay, again, we're dividing. We're not subtracting.
Now what
21
happens,
divided by 7 is 3. Yes?
what happens if you ain't got an a value? So, like, you won't have an x squared.
then it's not a parabola anymore. It's not a quadratic function if you don't have an x squared. And we won't do this. You would just have a linear function.
It's question 1 on your homework assignment.
Oh, okay, we'll get to that.
Okay.
You're not going to set that equal to 0. You're just going to factor it out.
-2.
Okay, so this one's -2 equals 0. Okay, so 7x times 3x minus 2. Oh, yeah, no, there's no x on there, right?
Right.
Okay, so 7x, you set that equal to 0, and 3x minus 2, you set that equal to 0. Okay, divide by 7. X is 0. Okay, and then 3x minus 2, what do you do?
Plus 2.
Plus 2. Plus 2. 3x equals 2. And then divide 3, divide 3. X is, just leave it as 2/3, okay? Now, what does that mean? 0 and 2/3. Still really close together. That's really skinny. Still really skinny, but that's what that means, right?
Yes.
But it's frowning, you said? It should be
I
frowning.
said, but it's fine.
Oh, but it's fine. Okay. Oh, I thought you said it's frowning. Okay, it's not frowning. Yep. Good, 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 good. That's it. That's the greatest common factor method. Okay? Now, when you are doing difference of squares, here's how this works. Difference of squares is my favorite factoring method, by the way. Have I told you that before? Favorite way. Favorite way. Well, this is my favorite factoring method. Okay? I have a lot of favorites of other things, all right? So, difference of squares. I'm not going to look at this box a whole lot. You can look at that box if you want to. I don't care. That tells you like the formula for it. This is easy, okay? Difference of squares. Here is an example of difference of squares, okay? X squared equals 64. All right, I want to factor him down. You can do this a different way, but just hold your comments here for just a second, okay? You're going to do this a different way, but I'm going to show you the difference of squares method, all right? So I want to get this 64 onto the same side as the x squared, so I have 0 over here. X squared minus 64 equals 0. I have to get one side equal to 0. Everything else is on the other side, all right? Now, x squared minus 64. To determine whether that's a difference of squares, you look for the difference. Difference means minus. Does it have a minus sign? Yes. And can I take the square root of x squared?
Yes.
Can I take the square root of 64?
Yep.
Yes. So I break it down like this, just in 2 pieces. Okay? What is the square root of x squared?
X.
X, so x and x. What's the square root of 64?
8.
8 and 8. And what do I put in between them?
Plus and minus.
Plus and minus, all right? Now, I set both of those equal to 0. So x plus 8 equals 0, and x minus 8 equals 0. I subtract 8, so x is negative 8. And I add 8, so x is positive 8.
It's just plus.
Okay?
minus 8.
Now, you guys are like, why did you do that?
Yeah.
Why can't you just take this equation right here and take the square root of both sides? Right? Because the square root of 64 is 8. Now, you are more than welcome to do that. You are more than welcome to do that. But the reason why I like to break it down as a difference of squares is because I will never, ever, ever forget when I'm doing difference of squares to put the plus and minus in there. You can't forget plus and minus when you're doing difference of squares. But if you do it this way, if I just take the square root of 64, I might forget to put the plus and minus in there.
But it's just like
And then the
other
answer's
one
wrong.
where, like, you put in the square
Yes,
root by
we put in the
yourself.
square root by ourselves,
So we
yes.
have to put plus
So
and
you
minus.
have to put plus and minus. But if you forget that part, you want to do the square root or the difference of squares method, right? Because you can't forget the plus and minus when you're doing this way, right? Okay? This way, you might forget that plus and minus there. Okay? Does that make sense? So you are more than welcome to do it this way. All right. Now, I'm going to give you another example. And this is the last one because we're not going to do these other 3 until Monday. Okay? This is your other example. I'm going to do 4x squared minus 9 equals 0. Okay? This one you kind of have to do the difference of squares method. I mean, you don't have to, but we're going to, yeah. It's harder to do it this way. Okay? So, 4x squared minus 9. And we want to break him down into these 2 pieces. Now, is he a difference of squares? That he is. He has a minus, right? And can I take the square root of this guy? 4x squared. Can I take the square root of 9?
Yep.
Yes. What is the square root of 4x squared? 2x. So 2x and 2x. What's the square root of 9? 3 and 3, right? And what goes in between them?
Plus and minus.
Plus 3 minus 3, okay? So I do 2x plus 3 equals 0. And then minus 3 minus 3. 2x equals negative 3. And then what? Divide by 2, x equals negative 3 over 2. We'll leave them like that, right? Okay, now, the next one, 2x minus 3 I set equal to 0. Okay, there I add 3, so 2x equals positive 3, and divide by 2, x equals 3 halves. Okay, now, if you would like to cheat, which who doesn't like to do that, once you did the first one, right, once you set 2x plus 3 equal to 0 and you found that it was negative 3 halves, skip this part, because what's the other answer going to be? Positive 3 halves, right? They go like hand in hand together, so you don't even have to do this part, right? It's going to be, one of them's going to be positive, one of them's going to be negative. Again, what does that mean? What do those two answers mean?
0.
Okay, it's where they cross, right here and right here. Okay, that's what he looks like. Make sense? So we're trying to find those places without having to graph by using algebra, by factoring stuff down. Okay, so those two methods we did. We did the difference of squares method and the greatest common factor method. Good?
Yes.
Okay, that is all. Now, I'm going to give you your sheet. Oh, shoot. I want this recorded. If you're watching this video, pause for just a second, okay? Or, like, keep the video running, but keep listening because I want to give you your instructions on your homework, okay? If you have your homework sheet with you, I'll show you what I want you to do.
So what about the ones that aren't square? Can you explain those? Like your 6x minus 18, how can you go about solving that?
Okay. I'm going to pass it all down. 1, 2, 3.
I don't need
Oh,
to.
yeah.
I need Mr. Jones's 6-hour class to please report to Mr. Jones's room at this time. Also, Halloween dance tonight. If you have an out-of-town date and have not yet signed one up, you need to do that before you leave today. FFA sales forms are here in the office and also in the barn. If you need to pick one of those up, get those. Picture retakes are on Monday. If you need a picture retake form, they are on the table outside of the office.
Okay. All right. So listen to these instructions real quick, and then you can be done. This is your homework sheet. You only have to do 1 through 14 for Monday.
You said 1 through 12.
Oh, excuse me, 1 through 12. I'm sorry. I thought it was 14. 1 through 12 for Monday. 1 through 12 for Monday. Okay. Now look at these questions really quick. 1 through 12. Okay. When you're doing the greatest common factor method, you're pulling stuff out. These top problems, 1 through 6, they are not set equal to 0. Does that make sense? There's no equal 0. So what you're going to do is when you're solving these, you are just going to leave your answer in this form. Does that make sense? You are not going to set it equal to 0, right? You are just factoring them down. Does that make sense? Your answer will be left like this, okay? That is the same for number 7 through 9. Notice that 7 through 9 does not have an equals 0. So your answer will just be whatever left in parentheses. Okay, again, like maybe this. That's how your answer will be left, okay? The only ones that you have to set it equal to 0 are 10, 11, and 12, because those are equal to 0. Now, the reason why I do that is if you look at number 2, how are you supposed to break apart number 2 and set that equal to 0 when you have an x, a y, and a z happening at the same time? There's no way of doing it, so that's why you don't set it equal to 0. Does that make sense? So only on 10, 11, and 12 do you have to set that equal to 0 and solve for x equals. All of the rest of your answers should have parentheses in them, yes? Okay? Now, if you flip over to the back side, you need to do number 1 and number 2 on the back side as well. Okay? Notice number 1 is the greatest common factor not equal to 0. So you do not need to solve for x. Okay? Example 2, though, you do, and you need to graph it. Okay? So it's going to be a parabola, and your solution is going to be where it crosses that x-axis. Okay? Make sense? Any questions? All right, I'm stopping the video.